Good morning all. This is Satish Kumar. Now let us see the another video lecture series on applications of multirate DSP. See, before going to see that applications, sampling rate conversion for a rational factor I by D. In decimation and interpolation, the sampling rate conversion is achieved by integer factor because D and I are integers. The sampling rate conversion by a factor 1 by D involves the following steps. Perform interpolation by a factor I. Filter the output of interpolator using low pass filter, anti-imaging filter with the bandwidth pi by I. The output of anti-imaging filter is passed through another low pass filter to limit the bandwidth of the signal pi by D. Next one, anti-aliasing filter. When the input signal or to the decimated is not band limited, then the spectrum of decimated signal has aliasing. In order to avoid aliasing, the input signal to be band limited to pi by D for decimation by a factor D. The input signal is passed through low pass filter with a bandwidth of pi by D. The low pass filter is designed to avoid aliasing in the output spectrum of decimator. It is called as anti-aliasing filter. When X of n is applied to your anti-aliasing filter H of n, which can produce V of n, that can be applied to the downsampling sequence, which can produce the output of Y of n. Next one, anti-imaging filter. When upsampled by a factor I, the output spectrum will have I images in the period of 2 pi. See, each image band limited to pi by I. Since the frequency spectrum in the range 0 to pi by I are unique, we have to filter the other images. The output of upsampler is passed through the low pass filter with a bandwidth of pi by I. Since this low pass filter is designed to avoid multiple images in the output spectrum, is called anti-imaging filter. When X of n is applied to the upsampler, which can produce as V of n. Anti-imaging filter H of n, which can produce the output as Y of n. Now this is the sampling rate conversion by a rational factor I by D. When X of n is applied to interpolator, and then anti-imaging filter HU of L, and then anti-aliasing filter W of L, that can be applied to the decimeter sequence, which can produce the S Y of M. Similarly, X of n can be applied to your interpolator. See, anti-imaging filter and anti-aliasing filter forms the low pass filter H of L. That can be applied to the decimeter sequence, which can produce the output as Y of M. Next one, consider the sampling rate converter which performs the sampling rate factor by I by D. The discrete time signal X of n is first upsampled by an integer factor I, the band limited using a low pass filter, and finally downsampled by an integer factor D. When X of n is applied to the interpolator with respect to n with respect to e power j omega, that can be applied to a low pass filter, that is nothing but h of e power j omega, that can be applied to a decimeter sequence, which can produce the output as y of e power j omega. That can be converted into frequency response sequence. Next one, applications. Digital filter bank. Digital filter bank is a set of bandpass filter. It can be classified into two types: analysis filter bank and synthesis filter bank. See, analysis filter bank is a set of bandpass filter. It is used for spectrum analysis in which the signal into set of subbands. The analysis filter bank consists of m numbers of subbands. So the input signal is divided into m number of subbands V0 to V of m minus 1. See, H1 of Z, H1 of Z, H2 of Z up to H of M minus are the transfer function of M numbers of bandpass filter. Synthesis filter banks is a set of bandpass filter used to combine or synthesize the number of subband signals into single composite signal. The analysis filter bank accept the M numbers of subbands W0 of N to Wm minus 1 of N combined to give a signal as Y of N. So, a synthesis filter bank perform the reverse process of analysis filter bank. G naught of Z to Z of M minus of Z are the transfer function of M numbers of bandpass filters. See, this is the analysis filter banks. X of n can be applied to your H naught of Z to H of m minus 1 of Z, which can produce the output as V naught of n to V of m minus 1 of n. That can be applied to your synthesis filter bank W naught of n to W m minus 1, Z naught of Z to Z of m minus 1. That can be all these filter banks are added, which can produce the output as Y of n. Next one, subband coding of speech signals. In subband coding of speech signal, the speech signal is divided into subbands, decimated, encoded, and transmitted to the receiver system. On the receiving side, the subband signals are decoded, interpolated, and synthesized into original speech signal. The transmission side, the input signal is split into m number of non-overlapping frequency bands using the analysis filter bank. It consists of bandpass filters. The output of each bandpass filter is decimated by a factor d. The output of decimators are encoded and transmitted. The output of interpolators are applied to the synthesis filter bank consisting of m number of bandpass filter to recover the original signal. Speech signal that can be applied to your different types of bandpass filter up to 1 to m that can be applied to your decimated sequence that can be applied to your encoder, which can produce the output as transmitted m subband speech signal. This transmitted signal received a subband signal that can be applied to a decoder, and then interpolation process starting, and then again we can apply to your bandpass filter. Finally we can going to add, which can produce this synthesized speech signal. This is the subband coding of speech signals. Next one, quadrature mirror filter bank, that is called as QMF bank, are the filter bank with complementary frequency response. The basic building blocks of QMF bank is a two-channel quadrature mirror filter. The two-channel moderator consists of analysis section and synthesis section. X of n can be applied to low-pass filter and high-pass filter. It can be decimated by a two sequence, that is nothing but analysis section. It can be interpolated by 2 and then can be applied to your G naught of Z to Z1 of Z, that can be going to add, which can produce as X dash of n is nothing but synthesis section. Next one, frequency response of QMF bankers with respect to H of e power j omega. It can be constantly and then decreasing, that is nothing but H naught of e power j omega. And then H1 of n means slightly increasing and then constant gas H1 of e power j omega. The meeting point is nothing but pi by 2 with the cutoff frequency. Next one, we can see the assessment. In decimation and interpolation, the sampling rate conversion is achieved by an integer factor IND. The fine anti-aliasing filter, the low pass filter is applied to the is in order to our low pass filter in order to avoid the aliasing in the output of the analyzer is nothing but anti-aliasing filter. The digital filter banks can be classified into two types. They are called as analysis filter bank and synthesis filter bank. In subband coding of speech signals, the speech signals are divided into subbands, decimated, encoded, and transmitted to the receiver system. Synthesis filter bank performs the reverse process of analysis filter. The fine digital filter bank, it is a set of bandpass filters. The two QMF channel consists of dash section and dash section, synthesis section and analysis section. Thank you.